Hello, so this question is from Google. So basically you are given an on-direct graph and then that might contain a cycle. So you can just basically read over it and then so the task is to visit all of the nodes and then check whether or not if there's a cycle in the graph. So quickly just go over the diagram. So the graph can be like this. So it's on-direct, right? So there's no error. So it might be like this, something like this, right? So in order to make this graph in a cycle, whether or not they are going to be like what a connection over here or a connection over here, like you trying to make this into a cycle, right? And then yeah, this will be like the first task. And the follow-up is check whether or not this validated of a cycle in the graph. Second value. Alright, the follow-up will not be necessary. I'm just going to explain like how are you going to build a graph and how are you going to make sure there's a cycle in the graph. So basically this is just my assumption. You're giving the n and also the list of lists, which is adjacent list. I mean, you can definitely think about this is going to be, the from to given this. So you're going to have like something like this. So this is going to be 0 to 1, and then 1 to 3, and then 2 to 5, something like this, and so on, right? So you probably given like this, and then you just need to traverse. All right. So basically, I'm going to have a visit node for every single n, and then if there's no visit, then I'll traverse. So DFS is be like this. If this is going to be a current node, this is going to be parent, this is going to be the visit, and this is going to be the graph. So if you're going to you're going to mark the current node as a visit, traverse the neighbor. If the neighbor doesn't visit before, you're doing the recursion code, and then until this is true, then you return true, which is going to be a cycle. Otherwise, you will comes to here. So you're going to make sure like if the neighbor you traverse that does not equal to parent, then you know like this might be a cycle, right? Because where's my so this is going to be your self node, and this might be your parent, right? P, and this is going to be node, and then you probably have another node right here, W, something like this, and then you come back to the P. Like this is the cycle. So this is how you're going to make sure, like first of all, like the neighbor for n is W and P, right? But P is your parent initially. I'm saying initially, and then your neighbor is W, and later on your W will connect back to P, and then you want to make sure the neighbor doesn't go to parent, and this will be given by here for sure. So this is just my assumption. So the idea is pretty straightforward. You traverse the graph and then mark the node as a visit, and check if the node are the parent of the node is equal to the current neighbor. If they are going to be a cycle. Otherwise, it's just return false. So this will be a standard of question to visit the graph. All right, see you.